Good morning to all of you. Welcome to you all on the IMS Get Academy platform. Bharat, Shubham, welcome. So in the last class, we have seen about the integration of signal waveform, how to directly integrate the signal waveform by using the graphical approach. That short trick we have discussed in the last class. Also, we have hands proof. If you will write the mathematical equation and then integrate the equation, again you will get the same diagram. So dear student, in the last class, from the last two classes, we had a discussion on how to write the mathematical equation and how to make the curve from the equation, and after that integration of signal waveform also we have discussed. So today's class is dedicated for differentiation of signal waveform. We know that how to differentiate the mathematical equation, but today in today's class I am going to teach you how to differentiate the waveform in terms of ramp, step and impulses. So guys, let's start today's class. I think we are left with one or two questions as far as integration of signal waveform is concerned. This was the last question of last class. Just do reply fast. How many of you attempted this? How many of you guys already did this? Just do reply. Bharat. So here we got 8 volt answer. In the last class we have discussed this question, and this was the last question of last class. Today's class I am going to start with this engineering services 2018 question. You should read the question, guys. The question is, a pulse of plus 10 volt in magnitude and 2 seconds in duration is applied to the terminals of a lossless inductor of 1.0 H Henry. The current through the inductor would be. So student, do you know what is the voltage and current across the inductor and capacitance? So if I talk about the voltage, V equal to L di upon dt and V equal to 1 upon C integration of I dt. Here voltage waveform is given to you and asking for the current waveform. So we can also write I is nothing but 1 upon L integration of V dt. It means if you want to generate the current waveform I, then you have to integrate the voltage waveform. And student, here L value is also given, that is 1 Henry, and voltage waveform you can draw because it is given magnitude also and the time duration also 2 seconds. So if I will make a voltage waveform which is having the magnitude 10 volt and having the duration 2 seconds, then I can make the curve like this. Okay, sir, ye 0 to 2 second and the magnitude is 10 volt and it is my voltage waveform with respect to time. Now if I want to integrate this, guys, do reply fast. As far as integration is concerned, I told you in the last class, integration means we have to calculate the area of step. While the process of integration, the area of step will become the magnitude of ramp. Will become the magnitude of ramp. It means here we have to calculate the area, and area is nothing but what, guys? 10 into 2 is nothing but 20. It means from 0 to 2 second duration, we have to draw a ramp signal which will achieve the magnitude of 20, and after that we will be remain at constant. So this is nothing but your IT waveform with respect to time. I hope this part is crystal clear to you guys. I hope this part is crystal clear to you. Tell me yes or no. So now we have to also multiply with 1 by L, and do you know L value is 1 Henry? Because L value is 1 Henry, so that is why here the waveform will not affect, because 1 by 1 if you will multiply it will be 20 only. So the correct answer is what? The current waveform will be increases linearly from 0 to 20 ampere in 2 seconds and in the positive direction, and from there on it remained constant at 20 ampere. So correct answer is CSK. Correct answer is Chennai. Tell me guys, yes or no. Bolo beta, Bharat or Shubham, is it clear? Bharat or Shubham, is it clear? From the last concept, whatever we have discussed in the last class, you guys can easily solve this engineering services 2018 question. Now all of you guys please do reply. Shall we go for next now? Do reply प्यारे बच्चों. Yes. Shall we go for next now? Yes, actually. So now student make a heading. Okay. Now we have one more question. After that we'll start the differentiation. So here it is look like a rectangular pulse combination, and we have to integrate this. Okay. So what I will do, I will make some space here, guys. I will make some space here to construct this diagram. Okay. So you just need to tell me one thing. Okay. Let me take this line. Okay. So I will draw this curve first of all here, and just below to this I will integrate it. Just below to this I will integrate it. Okay. So here again the same diagram, the same exercise I am making like this, and just below to this I will integrate this. Okay. Just wait. Let me take here. I think it is visible to you all, guys. I think it is visible to you all. Yes. So if it is my x of t waveform, I need to actually integrate it, and I will going to integrate here minus infinity to t xt dt. The integration curve we will make here only. Okay. First of all, we have to make the diagram. Diagram is what? From -3 to +3 and 1, 2, 3 stepwise. Okay. So first of all, location you need to make -3, sir, -2, -1. Here is +1, +2 and +3. Correct? Yes. Now here the magnitude is look like this. Here we have a step. Again, step is continued till here. After that here. After that here, like this. Yeah. Now each and every student just do reply fast. If we talk about this value, if we talk about these values, then here we are having -3, here we are having -2, -1, here what we are having, guys, 1, here what we are having, guys, 2, and here what we are having, guys, 3. Yeah. Now you have to calculate the area. While the process of integration, just repeat the sentence with me, guys. All of you should repeat. While the process of integration, the area of step will become the magnitude of ramp. The area of step will become the magnitude of ramp. It means you have to calculate the area of this. What is the area of this, bacho? Because the magnitude is 1, sir, 2 and 3. Well, it is given 2 and 1. It is given in the last question, I think. Yes, 1, 2, 3. Yes. So area of the signal is nothing but 1 into 1 is 1. It means we have to draw a ramp signal here, which will achieve the magnitude 1. Which will achieve the magnitude 1. Yeah. Now after that, student, we have to check the area of this signal. What is the area of this signal now? Sir, area of the signal is nothing but width into height. So here width is nothing but 1 and height is 2. So area is 2. So area is 2. It means I need to draw a ramp signal which will cover the magnitude 2 distance. Right now already I achieved at 1. If I will travel 2 distance, I will reach 3 value, guys. I will reach 3 value. I hope it is clear. So I should make a line like this, like this. So it means here I will achieve the 3 magnitude. Yeah. Now tell me, guys, what is happening here. If I talk about this, sir, what is the area of this, guys? What will be the area of this? Just let me know. The area of this -1 to +1, this distance is nothing but 2, 3 to the 6. 6. It means again you have to make a ramp signal which will travel 6 magnitude. Still you are at 3. When you will travel 6 distance, definitely you will, I have less space here, so I am making like this. So you will achieve which magnitude, guys? You will achieve 9 magnitude. Because 3 plus 6, 9, na sir, 9. Each and every line has different slope. Each and every line has different slope. Yes, 9. So the maximum value is 9. Now after that, student, again we are having common area. And what is the common area, guys, now? What is the common area? Common area is nothing but 2 into 1, 2. So you will reach at again 11. You will reach this magnitude, that is 11. And finally one more. So 11 to 12. So final, and after that no common value. So constant. So this constant value containing 12 magnitude only. This is the way how to integrate because I am having less space, so it is little bit congested here, but I think it is easily understandable. You guys can easily understand this. Yes. Please do reply, प्यारे बच्चों. Shall we go for next? बोलो 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 जोर से बोलो. Yes or no? Bharat, to reply beta. Shall we go for next? Chali. Now I am going for next bachcho. Now you should make a heading differentiation of signal waveform. So here I will make two important note, just like the integration we have made. What is the two important note first? While the process of differentiation, the slope of ramp going to be convert into magnitude of step. So this is the first point we need to remember. While the process of differentiation, slope of a ramp signal convert into the magnitude of step. If slope is negative, then the magnitude of step will be negative. Similarly, student, the magnitude of step, while the process of differentiation, the magnitude of step signal going to be converted into the weight of impulse. Going to be converted into weight of impulse. I hope this part is clear to you guys. All of you has to reply fast. Both the pointers is completed. Both the pointers are covered. Yes. So now student, let us focus on this part. If I talk about this first diagram, definitely it is a ramp signal. You can easily observe from the diagram itself. Okay, for the large pen, this only, for the small tip, red pen. Okay. So student, because this is a ramp signal, because it is my ramp signal, so I have a scope to calculate the slope, and if I will calculate the slope, I should travel the difference y into x. So what is the difference in y-axis, guys? 1. What is the difference in x-axis, guys? 2. So slope is nothing but 1 by 2. It means while the process of differentiation, the slope of ramp will become the magnitude of step. So that is why magnitude will be half only, and this is nothing but the differentiation curve. If this is my x of t, guys, this is the curve of dxt upon dt. In the graphical way, how can we relate? Yes. So I think till now you guys don't have any single doubt. Shall we go for next, Bharat? I think you are getting sufficient time for writing parallelly. All of you try to make the notes also parallel in the class. And student, if you want that classes will be regularly conducted on the same time, 11 a.m. morning, continuous for 1 month, 2 month, 3 month, then you have to be regular in the live classes. Chali. Now student, otherwise we will convert into a recorded session and will upload. So student, this is what dxt upon dt. This time again you have to differentiate. So this is the x of t, and here you need to create, need to make dxt upon dt waveform with respect to time and with respect to time. So student, tell me here we are having one value, again we are having here one value. So you need to calculate the slope of this line. What is the slope of this line, guys? Slope of this line is nothing but difference in y upon difference in x. So 1 upon 1, slope is 1. While the process of differentiation, the slope of ramp will become what, guys? The slope of ramp will become the magnitude of step. Yes, sir. So tell me, bachcho, if I talk about the magnitude of step, it means the plus 1 magnitude I need to make. Yeah. And after that, what I will say, after that I need to take that, sir, we have a downward sign. Downward means we have a constant line, and the constant line differentiation is 0. So wherever you are right now, you have to just approach to 0 value only. That's it. Yeah. So this is the simplest way of differentiation. This is the graphical way. However, if you want to write the mathematical equation of xt, then the mathematical equation of xt is nothing but r of t minus, because it is downward, so minus r of t minus 1. So this is the second method, mathematical equation. And by using the mathematical equation, if I want to differentiate it, so it will be what? you know that in the differentiation r will be replaced as a u. So in the mathematical equation you will get ut minus 1, and eventually when you will see the curve of this, it is exactly satisfy the equation. So curve is also saying that ut minus 1, exactly same. So by using the mathematical equation also you can check, and you can go for the graphical approach as well. Just do reply beta. Shall we go for next? All of you guys just do reply fast. Shall we go for next or wait? Shall we go for next or wait, Bharat? Shall we? I think we should go for next. Chali. So here I am going for next. This is my triangular waveform. So in the last class we have seen that the integration of, in the last class what we have seen, that the integration of square waveform is, the integration of square waveform is a triangular waveform. That we have seen in the last class. That we have seen in the last class. Yeah. Now student, for this type part is not required, so I will make diagram like this, like this. So you should tell me, sir, here in the last class we have seen the integration of square waveform is a triangular waveform, and this time a triangular waveform is given to me. Triangular waveform is given to me. So now it is what? Its magnitude is 1, and this is my x of t. And this time I am looking for dxt upon dt. And you know that the process of differentiation says what? While the process of differentiation, we have to calculate the slope of ramp. What is the slope of this line? Slope of this line is plus 1, 1 into. What is the slope of this line, guys? Slope of this line is nothing but 1 upon 1, slope is minus 1. So now you should tell me, guys, here we are having plus 1 value, and here we are having 2 value. So tell me what is the slope, guys? 1 into 1, the slope is plus 1. So it means you have to make a step of plus 1 magnitude. You have to make a slope of plus 1 magnitude. So what you can do, the slope of the ramp finally is nothing but plus 1. After that, student, this line is going like this. You have to come downward, and downward means constant line, and constant differentiation is 0 only. So student, when you will reach at this white line, you already reach at 0 value. Now after that, what is the slope of this? Minus 1. While the process of differentiation, the slope of ramp will become the magnitude of step, because this time slope is minus 1. So the magnitude we should draw a minus 1 only. Should draw a magnitude of minus 1 only. So now minus 1 magnitude, and after that this line is going like this. We have to come a constant line. So constant line means 0 only, like this. After that we have a constant. After that we have constant. So this is nothing but my dxt upon dt, and this is my xt only. I hope till here you guys don't have any single doubt. I hope till here you guys don't have any single doubt. All of you guys, please do reply fast. Shall we go for next? All of you guys, please do reply fast. Shall we go for next? Shabash. Chali. Just let me know. Are you guys all writing the same? Chali. So now student, the next question is here. This is a very good question, and I'm just giving to you. I want that you should attempt this. I want that all of you should try at least. At least try to attempt, guys. Here is the scope of mistake. Just try to attempt. So this is my x of t waveform, 0 to t, and we have to draw dxt upon dt. So here is the waveform is look like this. It is given 0, 1, It is 2. It's given, guy. Tell me what is the slope of this line. The slope of this line is difference in y upon difference in x was 2. So do you want to try this, guys? Bharat, just try to attempt it. I am giving you 2-minute time. Try to solve this, guys. This is a very good question. Here is a scope of mistake. Here we have a scope of mistake. Try to solve it. All of you guys just try to solve it. तो चलिए वैदेही सिंह ने रिप्लाई किया. वेरी गुड वैदेही, क्या बात है. I am very happy that Vaidehi has replied. A pulse of amplitude 2 and the duration from 0 to 1. Okay, after that what? Very nice. So you are saying that, sir, we have to make a magnitude, we have to make a step signal which is having the magnitude plus 2, which is having the magnitude plus 2 for 0 to 1 duration. Ye. Are you saying this, Vaidehi? After that what happened, beta? After that what? Are you saying that it will be a rectangular pulse? Are you saying this, it is a rectangular pulse, Vaidehi? क्या बात है, क्या बात है. Very nice, very nice. So very good, बच्चों. I think Vaidehi, you have already attended the earlier lectures also. So slope, because student here we are having the constant value. So constant value 0 means when you will reach this white line, this horizontal line, already you achieved 0. After that you have to see that, sir, here we have a ramp signal. So here we have a ulta step. Here we have a ulta step, negative step, which is having the minus 2 value. So when you will differentiate it, you will get a impulse of minus 2 weight. Yeah. So this will be the complete diagram of dxt upon dt. Shabash Vaidehi beta. Shabash. You can also hence prove it by writing the mathematical equation. If you wish to write the mathematical equation, you should start like this. Sir, twice of r of t minus twice of r of t minus 1 and finally minus twice of ut minus 1. So this is the complete mathematical equation of xt. And if I don't want to make the curve, if I want to directly differentiate in the equation itself, then all the r will be u and all the u will be del. So here it will be twice of ut minus twice of u of t minus 1, and after that minus twice of del of t minus 1. It means at plus 1 location, we are having a decreasing impulse which is having the weight of minus 2. Shabash Vaidehi beta, shabash. All of you guys just do reply. Shall we go for next? Vaidehi, is it clear beta? Shall we go for next now? Shall we go for next? Vaidehi says that I have attended all the lecture. They were so energetic that I got addicted to them. Heads up to you, sir. Okay, thank you, Vedai, for your lovely words. Thank you for your sharing, for your response. Vedai, just find some time and just copy and paste this statement in the comment section, because maybe in the future learner will not see the live chat, but they will of course see the comments. So whatever your true feeling, you should share with all your juniors, with all your colleagues, and they should also know that who is Ankur sir, how they guys can get benefit by attending Ankur sir classes. Okay, chali. Thank you for your response, beta. Shabash. Chaliye. So this is again a very good question, guys. Try to solve it. We have to differentiate this. I will make the same curve here for you. You should try to attempt. Meanwhile, I'm making a curve here. I will make a small curve here because I have a less space here. So I will make a small curve. And just below to this, I will differentiate. Just below to this, I will differentiate here. So here we are having the waveform x of t with respect to t. And here you have to draw dxt upon dt with respect to time. So you should see here we have a magnitude like this. After that, one value, here is one value, okay, one. After that, we have a curve like this. At this point, we have a two value, and after that, we have a point like this. So it is -1, it is +1, it is like this. So now exactly at this point, what should we write, guys? We should write 1. We should write here 2 like this. So now you are differentiating, student. You can write mathematical, of course, sir. Very good, very beta. So first of all, you have to focus on the magnitude of step. I told you while the process of differentiation, the magnitude of step will become the weight of impulse. While the process of differentiation, the magnitude of step will become the weight of impulse. Weight of impulse. Yeah. So what is the weight of impulse here? From here to here, whatever the white line is given, it is after the differentiation, it will be only represented by a impulse which is having the magnitude 1. Yeah. Which is having the magnitude 1. Now you should calculate the slope of this line. You should calculate the slope of this line, guys. Tell me what is the slope? Difference in y upon difference in x. So if I talk about the slope, 1 to -1, difference is 2, and 1 to 2, difference is 1. So slope is nothing but -2. And while the process of differentiation, the slope of ramp will become the magnitude of step. Because the slope is negative, so the step signal that we are going to make, it should also have a negative value. So because slope -2, so from 1 to 2, we should achieve -2 value. And after that, student, what will happen? After that, we have a decreasing. So it means we are having a constant line, and the differentiation of constant is 0. So wherever we are, we have to immediately achieve, we have to immediately reach to 0, and after that throughout at 0 value only. Yeah. So this is nothing but the xt, dxt upon dt. You can also hence prove by the mathematical equation. If you want to write the mathematical equation of this, then here the xt equation is nothing but u of t minus twice of r of t minus 1, after that plus twice of r of t minus 2. So that's it. This is the only equation. So if this is the only equation, if you will differentiate it here only, then dxt upon dt, ut differentiation is del t. So this is your first del t. After that, minus ka twice of u of t minus 1 and plus ka twice of u of t minus ka 2. It means here is minus ka twice of ut minus 1 and plus ka twice of ut minus 2. So this exact mathematical equation is satisfied by this exact curve of dxt upon dt. I hope this is clear to you guys. Yeah. Every student just do reply fast. Is this crystal clear? I think it is clear to you guys. Shall we go for next now? Yes. Chaliye. So last question is also completed. This question also completed. Now it's time to solve this question. Try to attempt this one, guys. All of you try to attempt this one, because I need to differentiate just below to this. So I am making some space here. I am making two diagrams here. Why making two diagrams? Because I want to differentiate. I need to differentiate just below to this. So that is why you should try. Meanwhile, you should try, guys. Meanwhile, you should try. So here is the time limit is t. This is my x of t. This is my dxt upon dt with respect to time. So 0, 1, 2, 3. So here I am writing 0. Here I am writing 1. Here I am writing 2. Here I am writing 3. 0, 1, 2, 3. And here we have the pointers like this. Like this. So this is minus 4 and this is plus 5. This is 2. Yeah. So what is the magnitude, guys? 2 and 1. So first of all, you have to check. This time we have to differentiate, not integrate, differentiate. It means while the process of differentiation, the magnitude of step will become the weight of impulse. It means what is the magnitude here? Plus 2 magnitude. So we should make a impulse of plus 2. We should make a impulse of plus 2. So now student, you should tell me, sir, from here to here we are having a decreasing step. From here to here we are having a decreasing step. So 2 to minus 4, 2 to minus 4 it is minus 6. It means as far as plus 1 location is concerned, we should travel to minus 6 impulse. Yeah. So this is my minus 6 impulse, guys. This is my minus 6 impulse. Yeah. This is plus 2, this is minus 6. Yeah. And after that, student, what is happening? After that, from here to here we have a positive step. So minus 4 to plus 5. Minus 4 to plus 5 matlab plus 9. So as soon as that plus 2 location is concerned, minus 4 to plus 5 matlab plus 9. Plus 9 magnitude impulse will be there. Plus 9 magnitude impulse will be there. Yeah. Plus 9 magnitude impulse will be there. Look like this. Just look like this. Is it clear or not, guys? Yeah. Just look like this. And after that you are having a decreasing step. You are having a decreasing step of minus 5. It means as soon as 3 location is concerned, we should have a minus 5 impulse. Yeah. We should have a minus 5 impulse. So this is nothing but dxt upon dt. This is nothing but xt with respect to time. So this is the final curve. You can also write the mathematical equation of xt here. Xt mathematical equation now very easy for you. The equation will be twice of ut. The equation will be twice of ut minus 6 of u of t minus 1. And after that, student, minus 4 to plus 5, minus 4 to plus 5 plus 9. You should write plus 9 into u of t minus 2. And after that, minus 5 into u of t minus 3. Each and every student just do reply. Is it clear? And finally, when you will differentiate the equation, all the u will be replaced as a del. So you will get twice into del t. You will get twice into del t minus का 6 into del of t minus 1 plus का 9 into del of t minus 2 minus का 5 into del of t minus 3. Yeah. So wherever is u, now it is del. Minus 6 plus 9 minus 5. Shabash. Do reply, guys. Is it completed now? I think it is completed. So now I am going for the next bachcho. Yeah. Again, it is quite easy as compared to if you already attended the last one. Now it is very easy, guys. Now it is very easy. Why easy, sir? Because this signal is only containing step. Signal is only containing step. Tell me yes or no. Because the signal is only containing step, so this is nothing but your f of t. This is nothing but your f of t with respect to time. And this is nothing but dft upon dt. So will be minus 1 to 0. So here I should write minus 1 to 0. And we are having the magnitude plus 1. and after that student till -1 as it is. After that we are having reaching this place 1. So student, as far as the concept says that while the process of differentiation you have to check the magnitude of step. What is the magnitude of step guys? +1. So because the magnitude of step is +1, this is -1 0, this is +1. So what is the area of this guys? 1 into 1 area 1. So we have to make a slope of, we have to make a, this not integration guys, this is just the weight +1. So +1 impulse unit, because it is differentiation you should make a impulse only. After that student, from here to here you will have a decreasing step -2, so you will have a decreasing impulse of -2 weight, and finally you are having here +1 step, so you should write here +1 impulse, So it is quite easy actually guys, quite easy as compared to last one. This is u of t +1 minus ka twice of ut and plus ka 1 into u of t -1. Yeah. This is my ft equation. So of course if I will differentiate it, I will eventually get del of t +1 minus ka twice of del t and plus ka del of t -1. Yeah. Plus ka del of t -1. I hope this part is crystal clear guys. Just do reply. Is it clear? All of you प्यारे बच्चों, just do reply. Is it clear? चलिए. Tell me प्यारे बच्चों, here what is happening? This is a trapezoidal waveform बच्चों. This is a trapezoidal waveform and this time you have to differentiate this. This time again you have to differentiate this. So this is my trapezoidal waveform, sir. I have to start my signal from the value of -1. So I am starting from -1, 0, 1, 2, 3. So from -1 to +1, we should make a curve like this. After that 1, 2, 3 like this. And after that 3 to 5 like this. It is actually 3. It is actually 5. Constant. Yeah. So this is my curve and here I need to just differentiate. We are differentiating guys, okay? Differentiation waveform. So what is the short trick says that this is my x of t guys, and if this is my yt, it is given. So if I am looking for dyt upon dt, then what should I do? While the process of differentiation, the slope of ramp. So here is what is the slope? The magnitude is 1, sir. So slope is difference in y 1, difference in x 2. So slope is half. The slope is half. So while the process of differentiation, the slope of ramp will become the magnitude of step. Magnitude of step, it means from -1 to +1, we should make a magnitude which is having the value of +half. After that student, here we are having decreasing, so it means constant wherever you are, you should achieve 0 value. After that student, you are right now at 0. But once you will take this at 3 value, you have to calculate the slope of this line. What is the slope of this line guys? Difference in y, that is 1, difference in x, that is 2. So slope, because decreasing, so -half. So it will achieve at -half step. It will reach to -half step. And after that we have a constant line. So constant line, it means immediately we need to jump to 0 and thereafter always at 0. Yeah. So this is nothing but the differentiation of a trapezoidal waveform. So student, what you can say that the integration of a square waveform is always a triangular waveform. The integration of square waveform is always a triangular waveform, and the differentiation of a triangular waveform is always a square waveform. बोलो बच्चों हाँ या ना? बोलो बच्चों बोलो. So here we are having +10 volt, -10 volt, 0 to t second. A triangular wave voltage shown in the figure is applied across the terminal of a 0.5 pure capacitor at time t equal to 0. The corresponding current waveform is. So again a very good question guys. You should tell me directly, can you solve this? Directly can you solve this guys without using notebook and pen? So okay, so I will make this waveform in the next slide. So this here is my waveform, and I will draw the, and after that we will check the options, because I am explaining by a conventional approach. However, by using the short trick you can easily solve this. So minus 10 volt to plus 10 volt and 0, 1, 2 here. Okay. So you should make a curve like this. Like this we have a triangular waveform. So actually it is 0, 1, 2. This is 10 volt. This is also minus 10 volt. This is 0. This is 1. This is 2. Yes or no? 2, 3, 4. ये 3, ये 4, ये 5, ये 6, ये 7. Like this we have. Now student, this nature says that, why differentiation I am asking, because here the triangular waveform voltage is shown in the figure across the terminal of a 0.5 pure capacitor. You know that voltage V is equal to 1 upon C integration of I dt. So I is nothing but C dV upon dt. So if you are looking for the current waveform, you have to differentiate the voltage waveform whatever is given. And the capacitance value you have to provide the amplitude shifting as well. So IT is nothing but capacitance value is 0.5 matlab 1 by 2, and here you need to write dVt upon dt. Here you need to write dVt upon dt. Is it clear or not, बच्चों? Is it crystal clear or not, प्यारे बच्चों? Yes. So IT equal to half of dVt upon dt. It means I need to differentiate this waveform. So I should calculate the slope of this line. What is the slope, guys? Difference in y, that is 20, and difference in x, that is 2. What is 20 upon 2? The 20 upon 2 is nothing but 10. So we are going to start from here minus 10 volt. I am just starting from 0 plus region. If exactly at 0, then of course we have to reach at step 10. So ideally we should have a impulse also at 10, at t equal to 0. But because we are looking for t equal to 0 plus, the curve going to start at minus 10 volt, and here exactly at 2 value, because now it will first of all achieve the constant value. So constant means you already reach here, and after that slope of this line. So slope of this line is nothing but, this slope is minus 10, sir. So this slope is plus 10. So you should achieve plus 10 volt, plus 10. Or not volt right now because it is ampere only. So 10 ampere. Yeah. After that till 4 you have a constant. After that similarly the same pattern. After that similarly the same pattern like this. What you need to do ultimately you have to provide the scaling with half also. So ultimately when you will provide the scaling with half, so you will get the 5 ampere here and minus 5 ampere here. And this is the only current waveform, and that is only given in the option number B for Bombay. So correct answer for this question is B for Bombay. Yeah, B for Bombay. All of you guys just do reply fast, yes or no? Your options are so silly because of course triangular waveform is a square. Triangular differentiation is square only. So square only and A and B. So C and D definitely wrong. And because initially you are having a decreasing step, so here is plus A, so this is also wrong. So this is how you can directly solve without using notebook and pen. You can save your time by using the concept. If you have a strong concept that allow you to solve the question within less time by fraction of second by using the option elimination approach. So I hope this part is crystal clear. Shall we go for next now? चलिए बच्चों, just let me know how to solve this. Minus infinity to infinity x of t dot del dash t minus 1.5 d. Do you know the property of doublet signal? Here we have a doublet. So the answer is nothing but minus ka x dash of 1.5. This is the only answer. It means if this is x of t, and can you make dxt upon dt? Yes sir, we can make dxt upon dt waveform easily. Because we know that the differentiation of a triangular waveform is always a square waveform. It means from 0, 1, 2, we should make a curve like this. From 0, 1, 2, it should make a curve like this. This is plus 1, this is minus 1. Plus 1, minus 1, like this, yes. and exactly at 1.5 place, what is the magnitude that you need to check. So answer is nothing but what, guys? Minus sign is already there, and x dash is this value 1.5, magnitude is -1. So your answer will be actually +1, because the slope is +1 and -1 na ye. All of you guys just do reply. Is this crystal clear or not, प्यारे बच्चों? Is it clear or not? So student, I will be more happy if you will interact in the live chat, if you will reply in the live chat, if you will ask your doubt in the live chat, then it will be great, okay? So try to attend the live lectures morning 11 a.m. from weekdays, Tuesday to Friday. Every day we are having classes. So you can enjoy the classes, dear student. And again, I am saying you straightforward, if the students are not there in the live classes, then maybe we should stop this YouTube initiative, okay? And any one of you or any of your juniors want to prepare for the GATE 24-25 exam and want to join the structure course, structure classes, dedicated study material, 26 exercise books, 4,000 plus practice question, dedicated theory books, dedicated doubt solving portal, my plan mentorship session. If you want all these for your GATE preparation, you can today join IMS GATE Academy. If you are in the nearby area of Bangalore, you can visit our Jayanagar 3rd Block Center. And if you are from other cities, you can contact to the given number that is in the red strip. Whatever the student advisory numbers are given here, our student advisory team will help you. Whatever questions in your mind, you can write the question already in white paper, and you can ask all the questions coming in your mind. And once you have 100% clarity, then you can join our IMS GATE Academy under my guidance, okay? Whether you have mechanical branch, civil branch. So here student, if you want to prepare for the GATE exam, और अगर आप कोई कमी नहीं छोड़ना चाहते प्रिपरेशन के लिए, and definitely you can come to IMS GATE Academy, and under my guidance you can study and you can prepare for the GATE 24-25 exam. चलिए बच्चों, so that's all from today's class. Because this is the last question of differentiation of signal waveform. In the next class, we will start the classification of signal waveform, classification of continuous time signals, and where we will discuss the periodic and non-periodic signal first of all, and followed by even odd signal and energy and power signal, very very important. Okay बच्चों, चलिए. So bye bye, take care. That's all from today's class.